Okay, guys, what we're going to be talking about today is area of squares and rectangles. That's the focus of 8.3 lesson, chapter 8, section 3. So let's flip over and take a look at the objectives for chapter 8, section 3. Okay, first and foremost, objective 1, we're going to use the area equation of a square to answer questions involving squares. And then second objective is use the area equation of a rectangle to answer questions involving rectangles. And third and finally, find the area of composite shapes involving squares and rectangles. There's a class introduction problem. We won't have time to go over that. If you want to go back and kind of read that over and think about what's happening there. Um, First and foremost, let's just talk about some properties of squares. We won't talk about all the properties of squares, but I do want to talk about one of the properties of squares, by the way. And that's going to help us in talking about the area of squares. Okay, given square ABCD, there's a lot of things that are going on here in terms of the definition of a square and properties. But the one thing, or maybe two things, that we need to make sure that we recall is that if it's a square, it's got four right angles. See, a square is a parallelogram that is both a rectangle and a rhombus. Okay, so a square's got four right angles. And then the other thing I want to talk about is the four sides of a square are all congruent. Okay, those are the two things I just want you to have a base recollection of. Is let's recall that the four sides of a square are congruent. Why are we bringing that up? Is because if we're going to call side length DCS, then we need to call the other three segments the same variable. It doesn't matter which variable you use to denote the four side lengths of the square. My point is if you call one of the side lengths a variable such as, let's say, x, then the other three segments also have to be called S, because the four sides are congruent in a square. So the equation that we can utilize to find the space inside of a square. See, area is space inside of a two-dimensional space figure. To find how much space takes up a particular square, we're going to go capital A for area. Area equals side length squared. Now, maybe you're accustomed for squares saying, well, the space inside of a square is area equals length times width. Or maybe you would say area equals base times height. Okay, but if we're going to use proper denotation, area equals side squared. If we wanted to, we could talk about the perimeter of a square. Perimeter means add, and then if you're going to add up the four sides of a square, it's going to be perimeter is equal to 4 times s, or s plus s plus s plus s. There's some other properties of squares that we've covered in previous chapters. Not necessary to go over that here. So what you'll see in the table is the equation that I just wrote on the board that denotes how to find the space inside of a square. Okay, if we look at some examples, it says find the area of the given polygon. My apologies, the directions were supposed to say somehow denote to you that that polygon was a square. So given that this is a square, the space, or the shaded region there, which takes up the space inside the square, is going to be found by taking the side length and squaring it. Well, the area has to be the side length, 9, squared. So the area or space inside of this square is 81 square feet. 81 square feet. Now, remembering the perimeter, I know the directions don't ask you to find the perimeter around this square, but if it did, the perimeter around this square, okay, is going to be 9 plus 9 plus 9 plus 9, or shorthand 4 times 9, because there's 4 nines. So the perimeter is going to be 36 feet. Not square feet. Area is square feet, but dimensionally linear feet speaking, the perimeter is only 36 feet. Okay. Moving on to example B, if you're going to do another example, how do we find the space inside of this square? Again, we're using capital A for area. Area equals side length squared. Substituting in our given information, we have the side length, so it's 11 squared, which means 11 times 11. So the space inside of this square is going to be 121 square meters. If we wanted to find the perimeter, it would be 4 times 11. The perimeter would be 44 meters. Okay, example 2. Utilizing the same equation for the area of a square, area equals side length squared. Maybe we're not always looking for the side length, and maybe we're given the area and looking for what the side length is. Okay, so we need to read, pay attention when we're reading the questions. Example 2. If the area of a square is 36 square feet, what are the dimensions of the square? Okay, well, we know it's a square, so we know we're utilizing this equation. We're given the area, so we're going to substitute 36 square feet in for the area, equal to the side length squared. So we need to solve this equation to find the side length. Well, the inverse operation of squaring is to square root both sides. The square root and the square cancel each other, and we're left with s equals plus or minus the square root of 36. So the side length is equal to plus or minus 36 is a perfect square, so it turns out to be 6 feet. Now, why plus or minus? Because we're using the square root property, got to have two solutions there. However, length can be negative, so we're going to ignore the negative answer there and say the side length is just 6 feet. Okay. Example 3 says the side length of a square. So we're given the side length is 13 centimeters. Find the area. So again, we know it's a square, so we're using this area formula. We're given the side length, so we're going to substitute in properly. So the space inside of this square is going to be 13 squared. So the space inside of this square is going to be 169 square centimeters. Square centimeters. Okay. Moving on, let's talk about how to find the space inside of a rectangle. So the formula derived is area equals base times height. So if we know the base length of a rectangle and we know the height of the rectangle, we can then find the area. And of course, if we're given the area and one of the dimensions, we could find the missing dimension. But there's the formula there. I like to call the height of a rectangle the altitude, not the height. I like to call the height little a. And then, of course, the 6 feet represents the base. So 6 feet is the base. Um, 2 feet is what the formula has above there is the height. But I like to use a different small lowercase letter for the height, altitude, because I think it's less confusing. I want you to know this. See, the altitude is a segment that is always perpendicular to the base. So we need to just make sure we understand that. So when we're finding the area of a rectangle, we're going to find the base length and then find the segment that is perpendicular to that, which will be the altitude. So the altitude is 2 feet, base length is 6 feet. So the space inside of this rectangle is going to be the base length times the altitude, and 6 times 2 is 12. So we're talking about 12 square feet. 12 square feet is the space inside of this rectangle. Example 2, it says find the area of the swimming pool. Well, again, they want you to find the area, so we're solving for the area. We know it's a rectangle, so we're going base times altitude equals capital A for area. Substituting in our knowns, the base length is 24 feet, the altitude is 16 feet, and so the area inside this rectangle is going to be 24 times 16. Okay, 6 times 4 is 24, carry the 2, 6 times 2 is 12, plus 2, 14. Now, 1 times 4 is 4, 1 times 2 is 2. And we're adding, so we get the area equals 384 square feet. Now, a good question to have is, why in the world would you want to find the area around such a pool? One of the reasons is if any of you own a pool at home, you know that you cover your pool with a tarp. So how do you know how many square feet of tarp you need to cover your pool? And I'm assuming you would get a little bit more than 384 square feet to cover your pool, because you need some excess because you want to totally cover the pool. But one example of why you would want to know the square footage of your pool there is maybe because you want to buy a new tarp to cover your pool in the wintertime, assuming you live in a climate where you need to do such. Okay. Now in example 3, it says the area of the rectangle below is 54 square inches. Notice that we're given the area. It says what is the altitude of the rectangle. So we know the area and we know the base length, and they're looking for the altitude dimension. Again, it's a rectangle, so we're going to go area equals base times altitude. We're given the area, so we're going to properly substitute 54 in the for the area. We know the base length is 9, so we're going to substitute 9 in for the base length, which now tells us we're looking for the altitude, and so we need to solve for A. So I'll write the equation over here. Okay, so inverse of multiplying by 9 is dividing both sides by 9. Then we're going to get altitude equals 6 inches. So the altitude, which is perpendicular to the base, is 6 inches. Okay, third objective. How do we find the area of a composite shape involving squares and rectangles? Why would we want to do that? Well, if we had time to go back in the class opener, what we're talking about here is if this is the floor plan of your home, maybe you want to find the square footage using different area equations to find the square footage of all your bedrooms, your family room, all these rooms that you see. You want to find their square footages and then add those square feet at the very end to find what is the total area of your floor plan of your home. So think of it that way when we're talking about objective 3, composite area. We're going to find the area of the different, in this case, rectangles or squares, and then we're going to add those at the end, and that's going to be our total composite area. Okay, so example 1, find the area of each composite figure below. There's a number of ways you can do it, but first and foremost, I know the base length of this rectangle. The base length of this rectangle is 7 inches in length. I'm highlighting that in green. The altitude of that rectangle is 3 inches. So the area of this rectangle, using area equals base times altitude, substituting in 7 in for the base and 3 in for the altitude, we know the area of that rectangle I just shaded in red is 21 square inches. So the area of the rectangle in red is 21 square inches. Now, somehow, some way, we need to find the area of this polygon that I'm highlighting in green. Okay, well, first question is this. Do we know what this dimension is yet that I just highlighted in black? Well, no. I noticed that that is a horizontal segment in black. So in order to derive that length, I need to somehow add other horizontal segments or subtract other horizontal segments. So if we look way up here, this horizontal segment is 7. And this horizontal segment is 4. So if you take 7 minus 4, you get 3, which gives us the remaining horizontal segment there of 3. Now, moving on, we need to somehow find the length of this vertical segment in orange. Okay, so we're either adding other vertical segments or subtracting other vertical segments to get that vertical segment. Okay, so we know that this vertical segment is 6 inches, and we know that this vertical segment is 3 inches. Therefore, 6 minus 3 leaves us with 3 inches there. Now that we know that the base length is 3 and the altitude is 3, I won't call this a rectangle, I'll call it a square because it's 3 by 3. So the area of this square, using the proper equation, area equals side squared, is going to be area equals whatever the side length is squared. So 3 squared is 9 square inches. Okay? Now, to get the composite area, we're going to take the area of the rectangle, which I have in blue, 21 square inches, and add it to the area of the square in orange, 9 square inches. So for a total composite area of 30 square inches is what we have here. I'll leave B there if you want to mess around with that one and see if you can come up with the total composite area. But there's our example on finding the composite area here. That'll be all we have for today. Thank you for tuning in.